Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is find the pivot integer. Okay, so given a positive integer n, you have to find the pivot integer x. Okay, so let me describe this problem in my own words. Okay, first let me open the board. Okay, now so you will be given an integer n. Okay, and you have to consider all the numbers from 1 to n, and you have to pick a certain number x between these two boundaries. Okay, let's say I pick x here. Okay, so the sum of these elements including x, let's say this is the sum of first half. Okay, let's call this first half sum, and the sum of second half of elements, okay, including x, let's call this second half sum. These two should be equal. Okay, these two should be equal, and x should be picked such that these two sums should be equal. Okay, so let's say for example n was given to be 8. Okay, so from 1 to n is equal to 8, you have to pick a certain number such that sum of first half is equal to the sum of second half, and you have to return that x. Okay, so if x does not exist, then you have to return -1. Okay, so this is the problem statement. The sum of all the elements between 1 and x inclusively equals to the sum of all the elements between x and n inclusively. Return the pivot integer x. If no such integer exists, you should be returning -1. It is guaranteed that there will be at most one pivot index or element out of the given input. Okay, so you can return whichever value of x is leading us to the equal sum of these two parts. Okay, so equal sum of first half and equality of sums between first half and second half sum. Okay, so you have to return x, which will lead to this condition. Okay, and if x does not exist, then you have to return -1. So let's see the constraints once before discussing the approach for this particular one. So according to the constraints, n will be ranging from 1 to 1000 only. So let's discuss a approach that can be the most optimal approach out there. Okay, so what we can do is that we have to we can have a hidden trial method here. We can pick different values of x and see whether those values are leading us to the answer or not. Okay, so but we let's say we do such hidden trial method, then it will result in order of n time complexity. Okay, so why so? Because for every value between 1 to n, you will be picking up some value of x. Okay, so if the values of 1 to n were from 1 to 8, then you could have picked any value between 1 to 8, and to search for those values which are leading us to this condition, you would have to do a linear sum in worst case. Okay, so your time complexity would have been order of n. So can we improve this? Yeah, for sure we can improve this. How can we do so? we can do so with the help of binary search. We can apply binary search for the value of x. Okay, so how now question arises, okay, you have decided that you can apply binary search. Okay, so first of all let me write it here, binary search. And for those of you who are not familiar with what binary search is, I will provide a link of an article where you can read about binary search, and it will be explained in detail there. Okay, you can explore that article if you are not familiar with it. Okay, so now coming back to the problem, how can I apply binary search? How will I know how to reduce my search space here? Okay, how to reduce search space. So for that we can use a mathematical formula. What is that mathematical formula? What is the sum of first n natural numbers? Okay, sum of first n natural numbers. It will be n into n plus 1 whole divided by 2. Okay, so natural numbers, by natural numbers I mean from 1 to n only. Okay, so this will be the formula for the sum. Then how you will get the sum of first half? It will be very easy. If there is a certain value that you have picked for x, then you can just do x into x plus 1 by 2. Okay, this will be the sum of first half. And for the second half, what you can do, you can first of all find the sum of full sum, you can say. So sum of first n natural numbers, it will be n into n plus 1 by 2. Okay, so you can subtract this first half sum from full sum and add x to it, because x is to be included, okay, in second half also. So it can be full sum minus first half sum plus x. Okay, because this will eliminate this whole part including x doing this. So we have to add x because x is also included in second half also, so that's why. Okay, so with this you will get both first half and second half. So if let's say it is the condition, you are reaching at a condition that because of, and what will before talking about how to reduce search space, what will be your search space ranging from? It will be ranging from your left value will be 1 and your right value will be n. And whenever you will find a mid value, as we do in binary search, let's say mid num, then you will consider this mid num as x. Okay, so now coming back to how to reduce search space and how to return the answer. If let's say you have picked your mid num such that, or x such that it is leading you to this condition, then you will very easily return the mid num or x. Okay, but if let's say first half sum is greater than second half sum, then you for sure note that you have taken more elements that were required in this half, so you should be reducing the number of elements in this half. So you can, what you can do, you can reduce your right pointer that is there in binary search. Okay, so this one is your right and this one is your left. Let me change color here. Okay, so left and right pointers. So if let's say you have picked more elements in first half that were required, so you will reduce your right pointer to one value before x. Okay, so what will that value be? So right will be reduced to whatever will be the value of mid num, or say x minus 1. Okay, and if it's the other way around, let's say that your first half sum is lesser than the second half sum, then in that case what you will do, you will know that you have picked a lesser number of elements than you should have in first half. Then you will just, you know, change your left pointer here. So left pointer will be one value plus to the x value. So it will be, left will be is equal to mid num, which is also our x plus 1. Okay, so this is how we will manipulate our search space and reduce it. And this is how everything will work out. Now let's see the implementation. And if you are not able to find anywhere value of x that is leading us to this condition, or mid num you can say, then you will return -1 in that case when you will terminate your binary search. So what will be the overall time complexity here? It will be nothing but order of log of n. Okay, so now we have reduced our time complexity from order of n to order of log of n. Okay, and space complexity wise we will not be using any extra space. So let's move to the implementation part. So this is the implementation. Your left bound in binary search will be 1 and your right bound will be n. So I told you to find out the full sum. It will help us to calculate first half sum and second half sum. Okay, so then what you will do, you will find the mid num as we do in binary search, standard binary search, finding out a midpoint, okay, in the search space. Then you will find the first half sum. As I told you, this will be the formula that will be used. So x will be mid num here, okay, for first half sum. So indeed this is the formula. And for the second half sum, just like I told you the formula that you will be using. Okay, for full sum minus first half sum plus mid num. Okay, and if it happens that you are at a condition which was required, that first half sum is equal to the second half sum, then you will return your mid num, which will be the value of x. And these are the two cases in which you will reduce your search space. Okay, in this case you have picked less number of elements in first half than required. You picked lesser number of elements than required. And here it's the opposite case, that you picked more number of elements than required in the first half. Okay, here it's that you picked more number of elements in the first half. Okay, so at last you will return -1 if you are not able to find any value of x which is satisfying the condition of first half sum being equal to second half sum. And that is how you will be solving this particular problem. If you are still having any doubts or any queries in general, feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.